Hello, today we're going to look at linear equations. They come in three different flavours, we can say. Y equals mx plus c, and there's also Ax plus by equals c, and the point slope form y minus y sub 1 is equal to mx minus x sub 1. Now, this is the most common form that you'll see them. Here, m means the slope, but this is really called the gradient. This is the scientific term. The gradient is the slope. C is the y-intercept. The y-intercept, where the line crosses the y-axis. This is commonly called the standard form. Standard form. And this one is the point slope form. This is because we are given a point to use, and we have the slope, the gradient m, in this form. So, without further ado, let's have a look at what gradient means. If we consider this graph here, then we can say that any line at 45 degrees has a gradient of 1. Gradient equals 1. If we consider lines in general, if it slopes up from left to right, if it's going upwards, then it's a positive gradient, positive. And if it slopes down from left to right, then it's a negative gradient. So, very steep lines are very high values, and the same with very steep negative ones. This is a very high negative value. So now let's consider a graph. Say this graph, and we have a line, any line, straight line, and we have 2 points, and we want to find the gradient, the value of the slope, how steep it is. So we know this point, it's -1 on the x-axis and 1 on the y-axis, and this one is, let's say, 2 on the x-axis and 4 on the y-axis. So what we can see is the difference between -1 and 2 means that this line is 3 units long, 3 units that way, and the difference between 1 and 4 is also 3 units. And the equation for the gradient is given by the rise divided by the run. Gradient is equal to the rise over the run. So the rise here is 3, and the run, the horizontal, is also 3, which is equal to 1. So this is a 45-degree angle with the x-axis. Let's try another one. Let's say a steeper one this time. And we have 2 points here and here, and this is -2, 7, -7, sorry, 1 minus 1. So again, we need to see the difference between each of these. On the x-axis we have 3 units. On the y-axis, -1, -7 difference is 6 units. So again, the gradient, which is m, is equal to the rise, 6 over the run, 3, 6 divided by 3 is 2. So this is a steeper curve, as you can see. Now let's make one with a negative gradient. Let's have it quite shallow, and we'll say we have 2 points. Let's say we have 2 points, and this point is 5, -1, and this point is -4, 2. So we need the rise over the run again, which we make a triangle like this. We could do it this way too, but either way you'll get the same answer. The run is 5 to -4 is 9 units, and the rise from -1 to 2 is 3. Now m, the gradient, is equal to the rise, which is -3 units, -3, because we have dropped down to get to the next point. So this is the -3 value, and the run is 9. So this gradient is -1 over 3. Okay. Now let's move on to see how we can find the x and y intercepts. That is, the places where the graph crosses the x-axis, that's the x-intercept, and where it crosses the y-axis, that's the y-intercept. So in order to do this, let's have a look at the slope-intercept form. Y equals mx plus c, and we'll say that y is equal to 3x plus 4. Now the y-intercept in this form is always the value of c, so that's easy. That's the y-intercept. And why is it so easy? Well, because the y-intercept always occurs when x is equal to 0. When on this line you're at 0, it's where the line crosses the y-axis. So what we're really saying is we're setting this value to 0. So y is equal to 3 times 0 plus 4, which is equal to 4. So the c is always the y-intercept. Now if we consider the x-intercept, that happens when y is equal to 0. So if we set this equation like this, y is 0 is equal to 3x plus 4, we can say that -3x is equal to 4. So x is equal to 4 divided by -3. So the x-intercept is -4 over 3. So we can put these points on our graph. It's often helpful to do so. So the y-intercept is at x equals 0, 0, and 4. So that point is 0, 4. And this point we've just worked out is -4 over 3. And the y value is 0, 0. Okay. So to summarise these points, the x-intercept occurs when y equals 0, and the y-intercept occurs when x is equal to 0. So we'll keep those points in mind. Let's have another graph. Got a graph here, and let's say we have this line, and we are looking now at the standard form. Ax plus by is equal to c. So this is the standard form. We're going to find the x and y intercepts in the same way. So if we have, say, 3x plus 2y is equal to 4, then if we set y to 0, we'll find the x-intercept. So 3x is equal to 4 because this y is 0. So x is equal to 4 over 3. So y is equal to 0, x is equal to 4 over 3, 4 over 3, whoops, 4 over 3, comma 0. And to find the y-intercept, we set x to 0, so 2y is equal to 4, so y is equal to 4 over 2 is equal to 2. So 0, 2, 0, 2 are the points of the intercepts here. Very nice. Now let's look at the point slope form. This is where we have y minus y1 is equal to mx minus x sub 1. And remember, m is the gradient, and we're given a point, y sub 1, x sub 1. So say we have this point, 2, 7, and we have a gradient m is equal to 3. Then if we graph this, so we have a graph, we have a point, let's say 2 here and 7 here, and the gradient is 3. It's something like this. So let's say this is 0.27, and we substitute these values into this equation. So we have y minus y sub 1 is 7 is equal to m, which is 3, x minus x sub 1, this value 2. So this gives us y minus 7 is equal to 3x minus 6. So y is equal to 3x, adding 7 to each side, plus 1. And we can use this to find the x and y intercepts again. Set y to 0, 0 is equal to 3x plus 1. So 3x is equal to minus 1, x is equal to negative 1 over 3. So x is equal to negative 1 over 3. It's about here. That's the x-intercept. So for the y-intercept, we set x to 0. So if we set this to 0, we say y is equal to 1. So y is equal to 1, x is 0. So now we have 3 points. Our line is a bit like this. I've missed all 3 points. There you go. That's about our line. Okay. Now let's talk about parallel and perpendicular lines. Now, a parallel line, 2 parallel lines, are lines that are equidistant from each other at all points along their distance. That means the gradient m for each line is equal to each other. So m sub 1, m sub 2, m sub 1 for this line, and m sub 2 for this line, these gradients are the same. So if we have a graph like this, we have two lines, and say this point here is 0, -2, and this point here is 0, 5, then anywhere along these two lines you will be 7 units apart vertically. So now let's have a look at perpendicular lines. Let's say we have two lines. We call the first line L sub 1 and the second line L sub 2. This is the symbol for perpendicular. So L sub 1 is perpendicular to L sub 2. So let's have a graph, this graph, and we have this line and we have this line. Perpendicular lines are lines that have a right angle where they cross, and this means that there's some kind of relationship between their gradients. So let's say the equation for this line is y is equal to -half x plus 3, and let's write it on the graph. Y is equal -half x plus 3. Then we need to know the equation for this line, or we need to find it. Now there's a nice simple trick to this. The gradient of perpendicular lines, of a line perpendicular to a line that you know, the gradient for that is simply the reciprocal, the negative reciprocal of that. So the gradient of line 2 has gradient m sub 2, and that gradient is the negative reciprocal of line 1, m sub 1, and that's all it is. So the gradient here is -half for this line. So putting this in this equation, the gradient of line 2 is equal to negative of -half, negative, positive, flip these over. So our gradient of this line is 2. Some students can struggle with this idea, so it's worth doing another example. Let's say we have a line here and a line here perpendicular to it, and we know the equation for this line here is y equals 2x minus 1, and we want to find the equation for, or we just want to find the gradient for this one here. We'll call this line 2 and this is line 1. So again, the gradient of line 2, m sub 2, is equal to the negative reciprocal of line 1. The gradient of line 1 is 2, so the negative reciprocal of that is -1 over 2. So the gradient of this line is -1/2. Now let's look at how we can graph a linear equation with all the different forms that we've seen. Let's start with the slope intercept form. That is y equals mx plus b. Now this b in some parts of the world is a c, y equals mx plus c, but it's just a constant. It doesn't matter which letter you use, this is just the most common form around the world. So let's say we have the values needed, 3x plus 2, then we know that the y-intercept is at 2, so we have 1 point already, and we can make a table of values to do this. There are several ways to do it, but a table of values can be helpful. We only need 2 values, but to get the idea of what we're doing. So let's just put in some random values. -1, we know what it is at 0, so let's say 1, 2 and 3. When x is -1, 3 times -1 is -3 plus 2 is -1. Y is equal to -1. When x is 1, the y value is equal to 3 times 1 is 3 plus 2 is 5, and we keep doing these. 3 times 2 is 6 plus 2 is 8, 3 times 3 is 9 plus 2 is 11. So we can plot these values onto our graph and see where we are. When x is -1, y is -1, so about here. When x is 1, y is 5, about here. When x is 2, y is 8, about here. And when x is 3, y is 11, we can see where this is going, somewhere up here. And this gives us our line. Whoa, something like that. Maybe this would be better. Ta-da! So that's the slope-intercept form. Now let's look at how to graph an equation from standard form. Ax plus by is equal to c. Let's say we know all of these values of a, b and c. We'll say 3x plus 9y is equal to 1. Again, we could do a table of values, but it takes quite a bit of time to do it, and it's not necessary. We can just set y is equal to 0 and x is equal to 0, and this will give us 2 points, which is enough to draw a line between them. So if we start with x is equal to 0 first, then we have 9y is equal to 1, so y is equal to 1/9. And if we set y is equal to 0, then we have 3x is equal to 1, so x is equal to 1/3. So when x is 0, y is equal to 1/9, which is about here, let's say. And when y is 0, x is equal to 1/3, which is about here, let's say. So we know those 2 points. We can draw a line approximately like this. It's a bit like that. So that's the standard form. Now let's do the point slope form. Point slope form. How to graph this. So remember, this form is y minus y sub 1 is equal to mx minus x sub 1. So let's say we have a point that we know. Let's say this point is -4, say 3/2 on the y-axis. It's 1.5 units up. So y minus y sub 1 is 3/2 is equal to m. Let's say we know the gradient. Let's say it's -4 multiplied by x minus x sub 1 minus 4. A negative of a negative is positive, so x plus 4. So simplifying this, y is equal to negative 4x minus 16 minus 4 multiplied by 4, and then adding that 3 over 2 plus 3 over 2. So this is negative 4x minus negative 29 over 2. So we can substitute in now those values where x is equal to 0, and that will give us another point for this line. So if we say x is equal to 0, y is equal to negative 29 over 2, so it's down here somewhere. So our line looks a bit like this, a bit like that. You must bear in mind, of course, that these graphs are not to scale. They're just generally being used to illustrate the concept. Finally, let's consider horizontal and vertical lines. Let's say we have a vertical line here, and let's say we have a horizontal line here. Now, these lines have equations too, just like any other line. This yellow line is x is equal to a constant. Let's say that's 8 units. 8 units. And the same for the blue line. We'll say y is equal to about 3 units. That's 3 units. Now these have special qualities to them. This is of the form y equals mx plus b. Just in this case, m is equal to 0. So horizontal lines have a gradient of 0. So you just have a constant value. Y is equal to 3. In the case of a vertical line, the gradient is undefined. It's too large. It's sloping up too quickly. So m is undefined. This is the symbol we use for undefined. It has no gradient, you could say. That is, it doesn't have a gradient. Alright, well, I think that's about it for today. If you enjoyed the video, then subscribe, like, comment and share.